Bismillahirrahmanirrahim. Assalamu alaikum. We are doing chapter 11, and previously we discussed triangles and exterior angles to the triangle, and we learned a property that exterior angle is equal to the sum of opposite interior angles, and this is we are talking about with reference to a triangle. So let's do one more question regarding these exterior angles before we start quadrilaterals. Okay, let's do that. Exercise 11A and question 4C. Okay, in this question, a triangle is given and there is one exterior angle to a triangle, and this is an exterior angle to a triangle, and we know that this exterior angle is equal to sum of opposite angles, and these are the opposite angle to this exterior angle. Okay, now we have to find value of B and E. So, since we know that this exterior angle is equal to these interior angles, so it is simple. Since exterior angle equals sum of interior sum of opposite interior angles. So therefore 2E plus 3E is equal to 110 and 5E is equal to 110, so E is equal to 22. So if E is 22, this means that this is 44 and this is 66. Now we have two angles of a triangle, and we know that the sum of interior angles of a triangle is equal to 180 degrees, and since sum of interior angles to a triangle equal 180 degree. Therefore, B is equal to 180 minus 66 minus 44. So it is equal to 70 degree. Okay, so we have found the value of D as well. So we also know that there is another way of finding the value of D. These two angles are adjacent angles, and sum of adjacent angles to a straight line equals 180 degree. So what we can do here is D is equal to 180 minus 110, which is 70 degree. So we can find the value of D in a couple of ways. So either we can use adjacent angles property, or we can say the sum of angles interior angles of a triangle equal to 180 degree. And for this, finding the value of E, we have applied the property of exterior angles. Okay, so it was to revise what we learned previously. So let's start quadrilaterals now. So for that, okay, now we are going to do quadrilaterals. And the first thing, in triangles, what we did was the sum of interior angles equals 180 degree. But in case of the quadrilaterals, sum of interior angles equals 360 degree. Okay. So this is the first thing. Now let's take if we are talking quadrilaterals, we will take a rectangle and a square, and we will see there are some properties which are similar to both, and there are a bit of couple of properties which are not similar to both. So we'll see that. So first we'll take a rectangle and we have a square. So approximately this is rectangle, this is square. So now both have a property which is similar to both the quadrilaterals. Both have two pair Now, which are these parallel sides? For this rectangle, this is parallel to this, and for square, this is parallel to this. For rectangle, this is parallel to this, and for square, this is parallel to this. Okay. In case of we can write here this like this. So this is rectangle. So. And this is square, just to make sure that we don't forget this. So this was the first property. So the second property is opposite sides are equal. We can see in rectangle that opposite sides are equal, but in case of square, all sides are equal. Okay. Now let's come to the third property. Here in this case of rectangle, all angles are of 90 degree. And don't mind my drawings, but remember these angles are, both these quadrilaterals have 4 angles and all the angles are of 90 degree. So all angles are of 90 degree. It is also here, all angles okay. Now I'm going to have diagonals in both the diagrams. Okay, diagonals. pretty rough, but they are straight. Okay, before I take the property of the diagonals, I'm going to name the sides as well. B, C, D, and this is E, A, B, C, D, this is E. Okay. Now, both diagonals are equal. Both are equal. Okay. Now, these two diagonals are intersecting each other at E. These two diagonals are intersecting each other at E. But the difference is, in this case, the diagonals are bisecting each other at a 90 degree. Okay, this is 90 degree. Diagonals bisect each other at 90 degrees. Okay, but in this case, diagonals are not bisecting each other at 90 degree, but just to make sure that we are talking about a 90 degree here. Okay, in this case, AE is equal to CE and BE is equal to DE. Okay, so these are the properties of both the quadrilaterals, and pretty similar, except in this case opposite sides are equal, in this case all sides are equal. In this case, half of the diagonal is equal to the half of other diagonal, and in this case the diagonals bisect each other at 90 degree. This is important, and this is some difference between both the properties both the quadrilaterals have. So let's do some examples to solve the quadrilaterals, and by using these properties and the properties we have already learned regarding angles and the exterior angles. Okay, so let's do that. Okay, we're going to take example. We have a rectangle A, B, C, D, and we know that all the angles of a rectangle are 90 degree. A rectangle has 4 angles and all the angles are of 90 degree. And within this rectangle, and if we remember, opposite sides are parallel, we can say that this is parallel to this and this is parallel to this. Okay, and if you remember that such lines are normally between the lines which are intersecting, the parallel lines are the transversals. Okay, but here in this case we have to find the angles. The first angle we have to find is AED. So the first angle is A, E and D. So we have to find this angle. Okay, A, E and D. Okay, now to find this angle, it's very simple. This AED is a triangle, and we know that interior angles of a triangle are equal to 180 degrees. So consider triangle AED. So the angle AED equals 180. 180 is the total of the interior angles. I have this angle equal to 90 degree and 50 degrees, and this is 90 degree angle. So minus 90 minus 50. Okay, what do I have here? So 180 minus 140, so I have here 40. So this angle is of 40 degree. Okay, now I have to find angle CDE. Now this C, D and E, CDE, I have to find this angle. And we know that the corner of a rectangle is of 90 degree. Okay, so if the corner of a rectangle is of 90 degree, it means that the total angle here is of 90 degree, right? But we have to find this CDE, or what we are going to do to find this CDE. CDE is equal to, I have total angle is of 90 degree, so 90 minus, what am I going to minus here? I am going to minus ADE. Okay, which is 90 minus 50 is equal to 40 degree. This is 40. Now, while starting this example, I said these two are the parallel lines and this is a transversal. If we remember the property of the transversal intersecting the two parallel lines, there is a property of alternate angles. Since we know alternate opposite angles are equal. Okay, so this is a parallel line, this is a parallel line, and this is a transversal. So this angle is supposed to be equal to this. So here we can say this AED is equal to CDE, and we have, and this is equal to 40 equal to 40, and we have calculated the CDE angle through using a property of a quadrilateral as well, and we have calculated it using the property that when the transversal is intersecting two parallel lines. So this is a cross check. We have calculated angle CDE correctly. Okay. Now finally we have to find CED. CED. Okay. So since this is 40 now, this is 70. So it is simple. Again, interior angles of a triangle, because this CDE is a triangle. Okay. So CED is equal to 180 minus 70 minus 40. So 70 plus 40 is 110, so it is 70. Okay, this angle is of 70 degree. Okay, so we have now all the angles which were supposed to be calculated, and we have used the property of the quadrilaterals. We have used the properties learned when the two parallel lines are intersected by a transversal. We have used the property of the quadrilateral. Okay. So let's do another example. So here we have another rectangle, and there's a diagonal. We have to find angle A and angle B. Now, first of all, since we know opposite lines are parallel, and when the parallel lines are intersected by a transversal, opposite angles, opposite alternate angles are equal. We have just used this property. So we know that using that property, we know A is equal to B degree. So whatever the value is going to be of A, it's going to be the value of B as well. And we also know, using the property of the quadrilateral, that the angles, 4 angles of the rectangle are of 90 degree. If we know that, so what we can do now here, what I was saying, that A and B are equal. Now, to calculate A or B, we cannot guess. Okay, we know that the corner of a rectangle is of 90 degree, but 90 minus A, we don't know that. So let's suppose we have here angle. This is of 50 degree. Now we are in a position to calculate the values of A and B. So what are we going to do? A is equal to 90 minus 50. So A is equal to a 40 degree. So A is 40 degrees. Because we know that the corner of a rectangle is of 90 degree, and we have to find A. So we need another angle, and we subtracted it from the 90, so we got the value of A. So whatever is the value of A is also the value of B. So B is also equal to of 40 degree. Okay. So now let's take another example. I'm going to take a square. Okay, we have a square, and there are two diagonals within a square. So this diagonal is touching the corners, but this diagonal ADF is not touching the corners, right? Because we know that the diagonals of the square intersect each other at a 90 degree, right? But not in this case, because this diagonal is not touching the corner B. The diagonal is DF. So in this case, only the diagonal AC is touching the corners. So the diagonals are not intersecting each other at a 90 degree. First one thing. Now we are given angle CED, which is 80 degree. We have to find this A and B. Now to find the value for this A, if this diagonal have been touching this corner B, we would have said that this angle is of 90 degree, and half of that angle, subtracting A, we could have find the value of A, but not we are not going to do it like this now. Okay. First, we need to know the angles of this triangle CDE. But we know that this angle is of 90 degree. Okay. So if this is of 90 degree, then it means that the angle ECD is of 45 degrees. Okay. Now if this is 45, this is 80, and we need to know what is this. So this is angle EDC. (180 minus 80 minus 45). Okay. So this is equal to 55. So this is 55 degrees. And if this is 55 degree now we are in a position that we know that this corner is of 90 degree. Now if this angle is of 55 degree, now we are in a position to calculate the value of A. So A is equal to 90 minus 55, which is 35 degrees. So this is 35. Okay. Now, similar is the case here. This is also of, this angle is also of 45 degree. Now, what is this angle? If we remember, vertically opposite angles are equal. Vertical opposite angles are equal. So, this is also 80 degrees. Okay, and if you see this is a straight line parallel to this straight line, right? DC is parallel to AB and AF is a transversal. Okay, so if this is 55 degree, this is also, you can just extend this so that you are familiar with what I am talking about. So if this is 55, this is also 55. So angle AFE is of 55. And there was another way. The interior angles of a triangle AEF is equal to 180 minus 80 minus 45. So this was 55. So there are a couple of ways for finding angles. We can find this angle by subtracting the value of 45 and 80 from the 180 degree, because the sum of the interior angles is equal to 180 degree. Or we can say that DC and AB are parallel lines and this BF is a transversal, and if this is 55, this is also 55, and we have this angle. Now, we know that adjacent angles on a straight line equals 180 degree, right? Adjacent angles on a straight line equals 180 degree. So angle B is equal to 180 minus 55, which is 135 degree. So we have this value of B as well now. Okay, so we have used the previously learned properties and the properties of the quadrilaterals to find the value of angles. Hope you got some idea. So thank you very much for now, and don't forget to give me feedback. And yes, just a thing before I go, miscalculation, right? It is 125, because when you subtract 55 from 180, you get 125, not 135. I mistakenly. So it was my mistake. Now corrected. Okay, thank you.